These are radical functions. This is Unit 8. 8a is convert between rational expressions, rational exponents, and radical expressions. So we're just going to get started, and hopefully you'll pick it up as we go. Otherwise, in class, I will expand upon it for you. So the first one, we're converting 7p with the exponent raised to 3 over 2 to radical form. Radical form, these are square roots, cube roots, that's radical. So converting, so 7p is your base, that is your base, and whatever the base of the exponent is, that is what's going to go inside of the radical. So 7p is going to be inside the radical. Now the denominator, this is the radical that you're going to have. So this is the radical. So it's a denominator of 2. So it's going to be a square root. If it was a denominator of 3, it'd be a cube root. Denominator of 4, it'd be a fourth root. And then the numerator here, this becomes your exponent. So of the base, so the 7p can stay in parentheses, and then that is going to be raised to the third power, and this is in radical form now. Number 2, converting. So it looks very, very similar, but now it's, instead of 7p all being raised to the 3 over 2, it's just 7 times p raised to the 3 over 2. So now only p is the base. That's the only thing getting raised to the 3 over 2. 7 is not. So 7 is going to stay on the outside. And what kind of radical is it? Hopefully you're saying a square root. So the denominator is 2, so it's a square root. And then it's p to the third power. And that'll be it. Example 3. Now we are going to convert 343r to the third raised to the negative 1/3. So the first thing with exponents is, if it's a negative exponent, we're going to make this, drop this in. Everything that's getting raised to that negative exponent, we're going to move it from, right now it's in the numerator. This all could be over 1. We're going to move it all to the denominator. And back that up. 343 r to the third, and instead of a positive 1/3 or a negative 1/3, it'll be a positive 1/3. By dropping it into from the numerator to the denominator, the exponent becomes positive. Now raising something to the 1/3 power, this is equivalent to, now we're going to change it to radical form, and it would be, since the denominator is 3, a cube root of 343 r to the third. And you've learned how to simplify this denominator, a cube root of 343 r to the third. So there's multiple ways you can do this. You can do this with the tree if you want, but 343 is 49 times 7, and 49 is 7 times 7, so the cube root of 343 is 7. We're going to simplify this. Now this is the simplifying part. We changed it to radical form. Now we're going to simplify this. So the cube root of 343 is 7. And then cube root of r to the third is just r. So my final answer here is 1 over 7r. So now we're going to go from radical form to exponential form. So we have, this is radical form. So to do the first thing, 5 is multiplied by the radical, so the 5 is nothing to do with when we're changing the exponential form. It's 5 multiplied by the cube root of 7x raised to the 4th power. So converting this, the 5 is just sitting on the outside, and then you can have the 7x in parentheses. It's a pretty ugly looking 7, but that's 7x, and it's going to be raised to the power 4, and then radicals 3, 4 over 3. So that's 5 times 7x raised to the 4 over 3. Next, changes to exponential form. So first, what is it? So we have 9 divided by the fifth root of 10x. There's no exponent, so if you want, there is always an exponent. The exponent's 1. So the very first thing we're going to do, 9 over, let's convert it. The 10x, that's underneath the radical. So that'll be your base. And it is raised to the 1 over 5. And if you want to continue with this and get rid of the fraction, we can take this whole base, 10x, to the 1/5, and we can move it all up to the numerator. So we can move this all up to the numerator. By doing that, if you do that, you will just make the exponent negative. And there you go. Example 6, now we got to simplify. I think the easiest way to simplify is with converting. You don't have to convert it. You can simplify with this. It's power to power, which is multiply. I'm going to actually simplify them. So we have 3x, and then it's a cube root, because it's raised to the 1/3. So it's a cube root of x to the 6 times 8y to the 13th. And now if I simplify from here, we have cube root of x to the 6 is x squared. So we already have a 3x on the outside. We're going to multiply that by another x squared. Cube root of 8 is 2, so times 2 on the outside. Cube root of y to the 13th. How many groups of 3 can I make out of 13? That is 4. So it's y to the 4th. And there'll be a y left over. So it's a cube root of y. Now let's simplify this all down. 3 times 2 on the outside, 6. X times x squared is x to the 3rd. Y to the 4th. And a cube root of y. And that is your final answer. Last example. Now we have to solve. Also with solving, I would convert to radical form. You can keep it in exponential form when you're solving, but I would change any exponents that are fractions, change them to radical form. It just makes it a lot easier. So 2, the x is the only thing that's the base, the 2 is not. It's 2 times x, so it's 2 over 3. So converting this, we have cube root of x squared plus 5 equals 27. And solving this, just solving an equation at this point. Because there's no fraction as an exponent, it looks a lot easier, which it is a lot easier. 22 divided by 2. You have the square root. Nope, sorry, I left off the cube. Probably yelling at me. Cube root of x squared equals 11. You gotta cube this. 11 cubed. It's 1,000. My goodness, 1,331. But bet one of you knew that. One of you out there knew that answer. And now we have to get rid of the square root. So we square root 1331. So in square rooting 1331, it is 11 square root of 11. And anytime you square root, you should always have a positive and a negative answer. So positive 11 square root of 11 and negative 11 square root of 11. This ends 8A. I will be answering questions in class. It might actually go over 8B also, but hope this goes well. Thanks.